everybody, it's Miss Jump and I am here for our problem of the day. This is our third day of learning and remember we're going to start each lesson with a problem of the day, okay? Now, I said earlier that our problem of the day can be any of the operations that we've learned in third grade. So it could be an addition, a subtraction, a multiplication, or a division problem. And our first two were subtraction, okay? So let's go ahead and look at our problem of the day. And it says a butterfly has 6 spots on its wings. How many spots would there be on 5 butterflies? So we need to decide what kind of operation is this. I don't think it's subtraction like the one that we've had because I'm not taking anything away. There's nothing left, okay? If I drew a butterfly, and y'all are going to learn that my drawings are not great here, but I do my best. All right, so if I have a butterfly and I put 6 spots on it, 3 there and 3 there, and I have, let's draw my butterfly, 3 spots on each side. Okay, so I have 5 butterflies. Each one has 6 spots on them. So how can I solve this problem? I could say 6 plus 6 plus 6 plus 6 plus 6, right, for each butterfly. And then I could say that 6 plus 6 equals 12. And then bring down that 6. And then when I add those up, I could say that 12 plus 12 is what? 24. And 24 plus 6 is what? 30. Okay? So that's one way that I could do this problem. I could add them all up. Now, does anybody see another way that you could solve this problem? All right, I have the same number each time, 6, and I have that times the 5 butterflies. So this is also repeated addition. We know that we could use repeated addition with also multiplication. So I could say 6 times 5. Now, what is 6 times 5? If I skip count by 5s 6 times, 5, 10, 15, 20, 25, 30, then I get 30, okay? Which is the same answer I get there. No matter how you're going to do it, you're still going to get the same answer. So how many spots would the butterfly have? Remember, we're going to have no naked numbers. So it would be 30 spots. So you could solve this problem either by repeated addition or by multiplication. Either way, you're going to still get the same answer. I am joining you on our third lesson. We've almost finished our first full week together. And I thought for today's lesson we would take it outside, but it's a little rainy here. So hopefully it's not rainy at your house today. All right, so we have been talking this week about ways to represent and show multiplication. And we've been talking about showing multiplication through models, which are called arrays, through repeated addition, through equal groups. We talked a little bit about the property of multiplication called the commutative property, and we're going to work a little bit more on it also today. All right, now we've said before that you can find arrays all over your house. You can find arrays in the grocery store. And so what I've done is I found another example of an array, and I know many of you probably have these at home, okay? So this example is a what? What is that? It's a Lego, right? Okay, and a Lego is a perfect example of an array because most of the pieces, not all of them, but most of the pieces have equal rows and equal columns. Now, if you look at this array and you look at the number of rows, how many rows are going across? How many rows do you count that are going across? 1, 2, 3, 4, 5, 6. So there's 6 rows going across. Then you count how many are going down and how many are going down. 1, 2, 3, 4, 5, 6, 7, 8. So if we wanted to draw this as an array, we would draw 6 rows of 8. Let me move my board over just a little bit. All right, so I'm going to draw 6 rows of 8. And if you will do that on your paper, go ahead and draw it and divide it into your 4 blocks. All right, so I have my 6 rows of 8 here. And that's how I can represent this model, this Lego, using an array. 6 rows of 8. All right, if I wanted to show this, let me scoot that up just a little bit. If I wanted to show this as repeated addition, what could I add here? I could add 6 plus 6 plus, or excuse me, 6 plus 6 plus 6 plus 6 plus 6. I can add that 6 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Or I could add my 8 6 times. Okay, now either way, what are they going to equal? What is 6 times 8, or how many little circles do I have in my Lego piece? I have 48, okay? So with repeated addition, that's going to equal 48. You can do repeated addition either way. Now let's go ahead and do my equal groups. I'm going to have 6 groups, so I'm going to draw my 6 circles. And then I want to put how many dots in each? 8. Okay, so put your 8 dots in each circle. All right, and then our new box that we added here is the commutative property. Now remember, the commutative property says that I can switch the order of the factors and I'm still going to get the same product, okay? The two numbers that you multiply together are called the factors. So I can say 6 times 8 is going to equal 48. The 6 and the 8 are the factors and 48 is the product. Or I can say 8 times 6 equals 48. Either way, either order that I put that in, I'm still going to get the same answer, or the product to the multiplication problem. Okay? So I can do that either way. All right. Now, for our next part of our lesson, we're going to be using some different, well, first of all, we're going to talk about different ways we can make 48, okay? So if you want to go get your manipulatives, anything that we've used this week, if you want to use cereal or dried beans or anything that your mom or dad has already given you permission to do, pause the video and run and go get that, okay? And you'll need 48 for our next activity, okay? So pause your video, run and go get that, and then we're going to talk about different ways that we can represent 48. All right, so we just looked at an array, one way to represent 48. And we said that 6 rows of 8 equals 48. And that's one way to make 48. So today what we're going to be doing, like we've done earlier this week, is we're going to be talking about some different ways to make 48. So I'm going to go ahead and put on our chart 6 times 8, because that's one way that we can make 48. Now, using your multiplication knowledge from 3rd grade, can you think of another way that you can represent and make 48? 1 times what would equal 48? Okay, good. 1 times 48. Okay, so let's go ahead and list that. Next, think, does 2 times anything equal 48? Yes, very good. 2 times 24 equals 48. Can you multiply 3 times anything and get 48? No, that one won't work. What about 4? Count by your 4s and see if you can get 4 times anything that will equal 48. 4 times 12 will work. What about 5? Will 5 times anything? If I count by 5s, I don't land on 48, so that one won't work. And then that brings me back up to my 6s, which I've already got. 6 times 8 is 48, okay? So these are all my different combinations that are going to equal 48. Now these numbers that go into 48 evenly are called the factors of 48. And let's practice putting those in order from least to greatest, which will help you in 4th grade and then later on in 5th grade also. All right, so we said that 1 times what's going to equal 48? 48. Let's put that one right there. And let's draw them and just connect those together. All right, and then I'm going to underline that one because I've already used it. All right, now what do I put next? If I'm going from least to greatest, which one of these do I need to use next? Very good. 2 times 24. So I'm going to put my 2 right there and my 24 right there, and then I'm going to draw my line connecting those factors. We know that they're a pair, that they work together. I'm going to underline that one because I've already used it. All right, we didn't have a 3 to go here. Do we have a 4 that goes next? Yes, we have 4 times 12. So let's put our 4 right there and our 12 right there and draw our line connecting those two, and then we want to underline that one showing that we've already used it. All right, so we've got 1, 2, 4. What pair of factors would go next? We've only got one left, and that's 6 times 8, okay? So let's put our 6 there and our 8 there. Now, all of these numbers are factors of 48. They are going to go into 48 evenly. And remember earlier this week, we said if a number has more than 2 factors, it is called a what? Starts with a C. Do you remember? It's a composite number. Very good, okay? So, is 48 composite? Yes, it is. All right, so 48 is a composite number. All right, now for the next part of our lesson, I want you to take your manipulatives, your beans, whatever you're using, your cereal, whatever you're using, and I want you to count out 13 pieces next, all right? So count out 13 pieces. And we're gonna talk next about different ways to make 13. All right, so hopefully you've got your manipulatives and you counted out 13 different manipulatives, okay? And what I want you to do is I want you to just take just a minute and I want you to build as many arrays as you can with your 13 tiles or your 13 cereal, whatever you're using, okay? And as you're building those, I want you to do it on your own for just a minute. And then as you're doing it, I want you to record all of the different ways that you were able to make 13. All right, so hopefully you've got some great arrays for 13, okay? So I would like for you to, let's think about different ways. You've had time for you to plan and for you to write it on your board. So one of the easiest ways to make 13 is what? You can always know that 1 times that number is going to equal 13, okay? So let's go ahead and put 1 times 13. All right, what else did you get next? Does 2 times anything equal 13? Nope, I can count by 2s. 2, 4, 6, 8, 10, 12, and 14. So I skip over that, that doesn't work. Does 3 times anything equal 13? Nope, that won't work. I can count by 3s. 3, 6, 9, 12, 18, but I won't land on 13. What about 4s? 4, 8, 12, 16, so I don't land on it with 4s. What about 5s? 5, 10, 15. I don't land on it there. Did you find any other combinations or any other ways to make 13? Nope. This is the only way, the only array that's going to make 13 is 1 times 13. Now you could flip-flop that and say 13 times 1, but you still only got these two factors, okay? So if we make our sheet next that says factors of 13, that's easy. How many factors of 13 do we have? We have 2, 1 and 13. Now, when we finished 48 a minute ago, we said that it is a composite number because it has more than 2 factors. Is 13 a composite number? No, it's not. It only has 2 factors, 1 and itself. So if a number only has 2 factors, 1 and itself, then it is not a composite number. 13 is a number that is called a prime number. Okay, so a prime number only has 2 factors, itself and the number 1. And we're going to be working on now, we're going to continue working on multiplication, but we're going to keep adding, we're going to keep talking about numbers and finding factors of numbers, and we're going to determine if those numbers are composite, do they have more than 2 factors, or are they prime, do they only have 2 factors. All right, so I will see you later. Remember that there's a review and extend that you can choose after this whole group lesson. Bye, guys.